So today we're basically taking the last two lessons and combining them, looking at if we have multi-step inequalities, just like we had looked at multi-step equations in a previous lesson. So when we're talking about converting between Celsius and Fahrenheit, we know that the Fahrenheit temperature is equal to 9/5 times the Celsius temperature plus 32. Now let's say we have a situation here. The normal body temperature of a camel is 97.7 degrees Fahrenheit in the morning. If it has no water by noon, its body temperature can rise above 104 degrees Fahrenheit. So if we said the Fahrenheit temperature is greater than 104, we're saying that that represents the temperature of the camel at noon. So let's look at if we want to see what the Celsius temperature would be if the Fahrenheit temperature is greater than 104. So we know that this is the Fahrenheit temperature right here. Let's say that is greater than 104 to find what values for the Celsius temperature are greater than 104. So in order to do this, we're going to have to isolate the variable c. So we'll subtract 32 from both sides. We'll get 9/5 c is greater than 72. Now I'm going to multiply both sides by 5, and I'm getting it 9c is greater than 360. Now I'm going to divide both sides by 9, and I'm going to get c is greater than 40. So if the Fahrenheit temperature is greater than 104, that means the Celsius temperature has to be greater than 40. Let's look at this inequality. Negative 7b plus 19 is less than negative 16. Again, we want to get this b by itself, so let's take this term 19 and subtract it from both sides. So we get negative 7b is less than negative 16 minus 19, which will give us negative 35. If we then divide both sides by negative 7, we get b is less than negative 35 divided by negative 7, which is positive 5. The problem is we divided by a negative, so that sign has to be flipped. This is incorrect. It's actually b is greater than 5. And you'll write that as a solution set, the variable b, such that b is greater than 5. Don't forget to switch that sign when you're dividing by a negative. Alright, so let's consider this written sentence. 3 times the number minus 18 is at least 5 times the number plus 24. Let's call this number n. So we say 3 times the number n minus 18 is at least. At least is telling us that it has to be at least this right side. So if it's at least the right side, that means it has to be greater than or at least equal to the right side. So it's greater than or equal to 5 times the number plus 24. So let's get all of our like terms on the same sides as each other. So we'll add 18 to both sides. We get 3n is greater than or equal to 5n plus 24 plus 18, which gives me 40. Let's subtract 5n from both sides. We get negative 2n is greater than or equal to 40. Now I have to divide by a negative number here, a negative 2. So I'm going to get n. Remember to flip my sign, is less than or equal to negative 20. I would write that n such that n is less than or equal to negative 20. I apologize, I just realized that 24 plus 18 is not 40. It's actually 42. But this equation would still turn out the same process. So 42, it would simply yield 21 instead of 20. Sorry about that. Alright, moving forward, let's say we have negative 3 times the quantity 2 plus 3b is less than or equal to 2. So we'll go ahead and distribute this negative 3. We're going to get negative 6 plus negative 9b is less than or equal to 2. So let's get our like terms together. We'll add 6 to both sides and get negative 9b is less than or equal to 8. So then we're going to divide both sides by negative 9. Remember, dividing by a negative makes me flip my sign. So I get b is greater than or equal to negative 8/9. So b, such that b is greater than or equal to negative 8/9. Alright, let's say we have 3d minus 2 times the quantity 8d minus 9 is greater than negative 2d minus 4. Again, always distribute when you see grouping symbols like parentheses. We get 3d minus 16d. Remember, we're distributing that negative 2 times negative 9, so we're going to get plus 18 is greater than negative 2d minus 4. Let's combine our like terms over here. 3d minus 16d is going to be negative 13d plus 18 greater than 2d minus 4. Let's combine our like terms. We'll add 13d to both sides. That'll cancel out my 13d. We'll add 4 to both sides, which will cancel out my negative 4. On the left, we get 18 plus 4, which is 22, is greater than negative 2d plus 13d, which gives me 11d. Divide both sides by 11. We get 2 is greater than d. Flip it around. D is less than 2. So we can write that solution set D such that d is less than 2. Right, let's say we have the quantity 8 times the quantity t plus 2 minus 3 times the quantity t minus 4. Is less than 5 times the quantity t minus 7 plus 8. Let's distribute. We get 8t plus 16 minus 3t plus 12 less than 5t minus 35 plus 8. Let's combine our like terms. We have 8t minus 3t, which is 5t. 16 plus 12, which is 28, is less than 5t. Minus 35 plus 8 is going to give me negative 27. So let's subtract 28 from both sides. So I'm going to cross out my 28. And let's also subtract 5t from both sides. Notice that it actually crosses out on this side equal also, because 0 is less than negative 27 minus 28, which is going to be minus 55. And we get this weird solution, 0 is less than negative 55. That is not true. So what we have here is no solution, and we'll just leave these braces empty because nothing is going to work if this equation supposes that 0 is less than negative 55. Finally, let's look at this scenario where we have 3 times p plus 4 is less than, or minus p plus 12 is less than or equal to 2 times the quantity p plus 12. So 3p plus 12, if we distribute that, minus p plus 12 distribute the right side, 2p plus 24. Combine my like terms, 3p and 2p gives me 2p, 12 and 12 gives me 24. Is less than or equal to 2p plus 24. I think we can see where this is going. Both sides are equivalent. If we subtract 2p from both sides, subtract 24 from both sides, we get 0 is less than or equal to 0, which is true. So this means that all real numbers will work for p. We can write it with this fancy r, meaning every number will work for that variable p. And with that, we will conclude our lesson on solving multi-step inequalities.